Welcome, space explorers. Before we dive into today's cosmic mystery, make sure to subscribe to our podcast on your favorite platform so you never miss an episode. At the end, we'll share how you can join our community and support deeper dives. Have you ever wondered what would happen if an object from a distant star system breezed through our cosmic neighborhood? In 2017, One-Eye Oumuamua surprised astronomers as the first confirmed interstellar object. 2 years later, Two-Eye Borisov, an unmistakable comet, swept by. Now, a third visitor, Three-Eye Atlas, has captured imaginations around the world. Some hail it as evidence of extraterrestrial life. Others call it a natural comet with nothing alien about it. In this episode, we unpack the evidence, separate science from speculation, and consider what Three-Eye Atlas can teach us about our universe. The object designated Three-Eye Atlas, also known as C2025Q1, was first spotted on the 1st of July 2025 by the Asteroid Terrestrial Impact Last Alert System, ATLAS, in Hawaii. This automated survey scans the skies for near-Earth objects. When astronomers observed this new streak of light, they quickly realized it was moving on a hyperbolic trajectory, a path that would carry it around the sun once and never return. Because its orbit is not bound to the sun and its inbound velocity exceeded escape velocity, scientists concluded it originated outside the solar system. Under the naming convention for interstellar objects, the prefix I denotes interstellar. Oumuamua I1 was the first, Borisov 2I the second, and this newcomer became Three-Eye Atlas. The Atlas suffix honors the Discovery Survey. Alternative designations like C2025Q1 reference the comet's nature and discovery date. From its first detection, Three-Eye Atlas sparked excitement because interstellar objects are exceedingly rare. They offer direct samples of other star systems. Unlike periodic comets that follow elliptical orbits, interstellar comets follow hyperbolic trajectories, with eccentricities greater than 1. Three-Eye Atlas's eccentricity is roughly 1.003, meaning it is barely bound even as it passes through the inner solar system. Its inbound speed relative to the sun is approximately 21,000 kilometers an hour, 130,000 miles an hour. At closest approach to the sun, on October 30th, 2025, it will come within roughly 1 AU of the sun and about 1.8 AU from Earth. After perihelion, gravitational interactions will hurl it back into interstellar space. This trajectory means Three-Eye Atlas is a one-time visitor. It likely formed billions of years ago around a distant star that was ejected, perhaps by a passing planet, into the emptiness between stars. Its current path indicates it may have originated in the direction of the constellation Sagittarius, from the thick disk of the Milky Way. Images from the Hubble Space Telescope on July 2025 revealed that Three-Eye Atlas has a compact nucleus, surrounded by a dusty coma. Hubble's high-resolution data suggests the nucleus is between 0.32 and 5.6 kilometers across. This size range places it between Oumuamua, thought to be less than a kilometer, and Borisov, roughly 0.4 to 1 kilometer. Observations also show a dust plume and tail streaming away from the sun, typical of comets. The fact that Three-Eye Atlas produced a comet and tail confirmed its classification as a comet rather than an asteroid or a purely rock body. This composition appears consistent with other comets. Spectroscopy from ground-based telescopes detect water, ice, and carbon monoxide. NASA emphasizes that nothing about its makeup suggests an artificial origin. In the wake of previous interstellar visitors, some people worried that Three-Eye Atlas might pose a collision risk. NASA's Planetary Defense Coordination Office quickly dispelled those fears. The comet will not come closer than 1.8 AU to Earth and possesses no threat. Its hyperbolic orbit ensures it will leave the solar system after its brief visit. What makes an interstellar comet different? The key factor is its origin. While ordinary comets hail from the Kuiper belt or Oort cloud, interstellar comets are born around other stars. Their chemical composition may differ depending on the environment of their birth. For instance, Two-Eye Borisov was found to have carbon monoxide abundance similar to solar system comets, hinting at chemical commonalities across star systems. Studying these objects offers clues about how planetary systems form, because interstellar comets are not gravitationally bound to the sun. They usually enter the solar system at higher velocities. Their orbits are hyperbolic or very elongated. They also have unknown dynamical histories. We cannot trace them back to a specific star yet. Shortly after 3I Atlas's discovery, Harvard astronomer Avi Loeb and others suggested it might be an alien spacecraft performing an orbit maneuver near the sun. This theory echoes the speculation around Oumuamua. Certain features, its size, forward jet, and orbital alignment could point to artificial design. He estimated a 30 to 40% profitability of non-natural origin and urged scientists to prepare for a possible mothership. However, NASA and most astronomers firmly reject this hypothesis. NASA's Tom Statler stated that 3I Atlas looks like a comet, behaves like a comet. Its dust, tail, and activity are exactly what scientists expect from an icy body warming near the sun. Loeb's anomalies, large size, forward jet, unusual composition, are either within normal ranges or based on preliminary data. As one astrophysicist noted, if it quacks like a comet, it likely is one. Scientific skepticism is healthy. Extraordinary claims require extraordinary evidence. So far, every credible observation of 3I Atlas fits the profile of a natural comet. While it is fun to speculate about aliens, the burden of proof remains on those making the extraordinary claim. Despite the UFO hype, 3I Atlas is sufficiently valuable, being only the third interstellar object known. It allows astronomers to compare comets formed around different stars with those from our own system. By studying its chemical composition, researchers can determine whether building blocks of life like water and organic molecules are common throughout the galaxy. Observatories across the world and in space, including Hubble James Webb Space Telescope, the Transiting Exoplanet Survey Satellite, Mars Orbiters, and even NASA's Psyche and JUICE missions, planned observation campaigns to capture 3I Atlas at various phases. The more data collected, the better scientists can refine models of comet formation, interstellar travel, and planetary system evolution. 3I Atlas exemplifies how a single celestial visitor can spark wonder, speculation, and serious scientific inquiry. While it is almost certainly a natural comet, its interstellar origin reminds us that the solar system is not isolated. Pieces of other worlds occasionally pass by, offering glimpses into distant cosmic environment. With each interstellar visitor, we learn more about the diversity of planetary systems and the likelihood of life elsewhere. If this journey through 3I Atlas inspired you, don't forget to subscribe and leave a review. Visit thebrokentruth.com. The link will be in the description to read the show notes, which explains further resources, and you can find links to join our Discord server and Patreon for deeper dives into the cosmos.
In a world built on hidden histories and half-truths, we've only just begun to peel back the layers. Because what you've heard tonight was never meant to be known, but you were meant to find it. If you're ready to go deeper, leave us a review, comment your thoughts, share this episode, and step inside the archives. Join the inner circle, where the real evidence is kept. This is the broken truth, because the truth isn't whole, it's broken.